Today we'll be talking about similarity of triangles. So the last video was on similar polygons. This is going to be specifically triangles. So just like we had our congruency statements for triangles, now we have similarity statements. And remember, similar means that they are the same shape, but not necessarily the same size. Okay, so we have a couple different statements. Our first one is angle-angle similarity, and we notate that by AA. And that just means if we have two angles of one triangle that are congruent to two angles of another triangle, then we know that those two triangles are similar. Okay, it doesn't mean that they're congruent, it just means that they are similar. So we have two pictures here. So if we know that angle P is congruent to T, so P is congruent to angle T, and we know that angle Q is congruent to angle S, then we know that these two triangles are similar. And remember, the way that we write the similarity statement, order is important. So P is with T, so they are in corresponding positions. They're both in the first position. Q goes with S, they're both in the second position. And then the last letter for each triangle, we have R and U. And then again, remember our similarity symbol is that little squiggle, like the top of a congruency statement. Okay, let's go on to the next one. So next is side, side, side. So that is notated by SSS, and yes, we did have a side, side, side that was a congruency statement. However, this one is for similarity, and it looks a little bit different. So for this one, if the measure of the corresponding sides of two triangles are proportional, they're not congruent anymore, they are proportional, then those two triangles are similar. So here we have PQ, which is this side here, goes with ST here. We have QR, which is this side, goes with SU, and then RP goes with UT. And so we set them up this way so that we get a ratio. And whenever you reduce those ratios, we would actually end up with 1x, 1 over x. Okay? Alright, so then we can give our similarity statement. We have triangle PQR is similar to triangle TSU. And again, just a reminder, when we're doing this ratio, that is finding our scale factor. So our scale factor here, I'll just show you one. So if we do PQ equals A over, we said ST, and ST is AX. So like I said, if we reduce that, we would get rid of the A's from both top and bottom, and we're left with 1 over the X. If we did the others, we would end up with the exact same thing. I'll just go ahead and show you here. QR over SU. So QR is B, and SU is BX. So again, the B's would cross out, and we're left with 1 over X. Okay? Alright, so let's go on to the last one. The last one here is our side angle side. So side angle side similarity is notated with SAS. And yes, again, we did have a congruency one that was also side angle side, but again, this is dealing with proportions and not congruent sides. So for this one, if the measure of two sides of a triangle are proportional to the measure of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So if we look here, we have PQ and ST. PQ with ST is proportional with QR and SU. QR and SU. And then we have our included angles. The angle between our two sides, those are congruent. So we know that these triangles are similar. So our similarity statement for this one, triangle PQR is similar to triangle TSU. Okay, and again, we could write out those ratios and see that those are actually going to be proportional. Alright, so let's get to some examples. So our first example here is a proof. Let me actually adjust this camera just a smidge. I want to make sure that you're able to see all of it. Alright, so for example 1, we're given some information here. I know this is really small, so I will read these to you. So we have segment PQ over AB equals segment QR over BC and RP over CA. Okay. We also have some angles here. So here's angle 1. We have angle 2. Angle 3 is over on this side. Angle 4 is down here in the corner. Angle 5 is the very tip. And then we have a dashed line here at DB and a dashed line over here at PQ. Okay, so what does that mean when we have that dashed line? Well, that means that they're congruent. Okay, so I am going to go ahead and start my proof here. So I'm going to start with my given. So I have PQ over AB equals QR over BC equals RP over CA. And I have those little dash lines, so I'm going to mark those too. So DB is congruent to PQ, and those things were all given to me. Okay, so now we're trying to prove that BAC, this big triangle, is similar to QPR, which is this little one over to the right. Okay, alright, so from here, the first thing that I'm going to do is I'm going to use this information and I'm going to plug it in here. So if we know that DB is congruent to PQ, we can actually substitute that in. So I'm going to put in DB over AB equals QR over BC, which equals RP over CA, and that's substitution. Okay, so then the next thing I'm going to be doing is I'm going to be looking here at these parallel lines. So I have DE is parallel to AC, and that's actually given to us as well. So then what do I know since those lines are parallel? Parallel lines cut by a transversal. I'm going to look at my transversal being BC first. So since those lines are parallel, we know that corresponding angles are congruent. So angle 3 is congruent to angle 4. If I look on this side with my parallel lines, I can also say that angle 2 is congruent to angle 1. Okay. And this is corresponding. Oh, I forgot my G. So we have corresponding angles there. So I'm going to go ahead and mark that on my page. I know it's kind of tight. So we have those. Now we know from this statement up here that the two little triangles are going to be similar. Now we're trying to prove that the larger one is similar to this one. So once we have this piece, then we can actually say, since we have DB, let's see here, we have one angle here, we have one angle here, and then this one is shared. Apologize, I was looking at the wrong piece. So we have 3 angles. So once we have that, we actually know that these two triangles are similar to each other. So we have triangle BAC is similar to triangle BDE, and that is angle similarity. So once we have that, we know also that triangle let's see, B, D, E is similar, this triangle over here. So we're looking at triangle Q, P, R because of this statement here. Okay. And this would be side, side, side similarity. Okay, so we have side, side, side. We have angle, angle. So once we know these two pieces, if you remember, we had a property called the transitive where we can pull the center part out. So then I can say triangle BAC is similar to triangle QPR, and that would be transitive. Okay? So we proved that these two were similar. We said these two were similar, so then we know that these two have to be similar. Alright, let's look at another example. We have another example here. So for this one, it gives us quite a bit of information over here. So we're going to look at that in just a minute, and we're going to determine which triangles in the figure are similar. Which triangles are similar. Let me adjust my camera 1 second. Alright. So I'm going to mark the information that they gave me. They said that FG is congruent to EG. So FG is congruent to EG. We have that marked. They said BE, which is this long segment, I'm going to mark that, is 15. They said that CF, which is this long segment, is 20. They said AE goes across here is 9, and DF, which goes across here, is 12. Okay, so we're looking to see which triangles we can prove being similar. Alright, so let's start out. We're going to be looking at seeing if we can find a scale factor that's going to be the same. So I'm going to look at AE over FD. Now AE is 9, FD is 12, so that gives me a scale factor of 3/4. Okay, so then the next thing I'm going to be looking at is these two sides. So let's see, AE, that would go with BE, would need to be on top. And this bigger triangle, that would be FC. So BE was 15, FC was 20. If I reduce that, dividing by 5, I get 3/4. So those sides are proportional. I don't know anything about this side or this side, so the next thing I'm going to do is look for angles. Looking for angles. Well, if I have this little triangle down here, this little triangle is considered an isosceles triangle. So I know if I have an isosceles triangle that the angles opposite of my congruent sides are also congruent. So I know angle CFE is congruent to angle BEA, and that's because it's isosceles. Okay, so now I have this side goes with this side. I have the bottom with the bottom, and I have these angles here. That is the included angle. So I can say yes, and I'm going to name them triangle ABCD. E is similar to triangle D. These are the ones on the outside. B was next, which goes with C. And E was last, which goes with F. Because of which one of our postulates did we use? We used side, angle, side, similarity. Okay? Alright. So that's all we have to do for that one. So we're going to go ahead and go on to another example. Let me do a little bit of adjusting here. I want to make sure you can see the whole picture. So here we're going to be finding AE, which is this one, and DE, which is this one. Alright? So for this one, since we have parallel lines cut by a transversal, we can say that those angles are congruent. So we have angle A is congruent to angle D, and those are alternate interior angles. What else can we do? We also have a transversal here, so we can say this one is congruent to that one, and that's going to be angle B is congruent to angle C. Those are also alternate interior angles. If you remember, we only have to have two angles that are the same. So triangle ABE is similar to triangle DCE, and this is by angle, angle, similarity. So since we know that those are similar triangles, we can set up our proportions. So this side goes with this one, so we have AB over DC, which is 2 over 5. And we also have AE over DE, which is x minus 1 over x plus 5. Those should be proportional, so we can actually set them equal to each other. So 2 over 5 equals x minus 1 over x plus 5. So then from here, we're going to be doing our cross multiplication or cross products. So I'm going to take 2 times x plus 5 equals 5 times the x minus 1. I'm going to go ahead and slide up here. So then I'm going to distribute 2x plus 10 equals 5x minus 5. Okay, so I was just distributing my 2 and distributing my 5. So then the next step here, I've got to combine my like terms. So I'm going to move my 2x to the right. So I have 10 equals 3x minus 5. I'm going to move my constant 5 to the left, so I'm adding 5. So I have 3x equals 15. And then finally, to get x by itself, I'm going to divide by 3, and I get x equals 5. Now they didn't ask me what x equals, they asked me for the length of the segment, so I'm going to plug that back in. So I have AE equals x minus 1, so that's 5 minus 1, which is 4. And then I have DE, which is x plus 5. X is 5, so 5 plus 5, which is 10. Okay? Alright, let's go on and do one more example. This one is a word problem. So this last example, Nina was curious about the height of the Eiffel Tower. She used a 1.2 meter model of the tower and measured its shadow at 2 p.m. The length of the shadow was 0.9 meter. Then she measured the Eiffel Tower shadow and it was 240 meters. what is the height of the Eiffel Tower? So we're going to do just like we did before, where we're going to be setting up our proportion and then finding the missing value. So setting up our proportion, for this one, I'm going to have the height of the tower over the height of the model. So tower over model. So for the tower, I don't know what that is, that's x. And then for the model, it's 1.2. So then from there, I'm going to take the shadow of the tower, which is 240, over the shadow of the model, which is 0.9. Again, using my cross products. So I'm going to be multiplying 1.2 times 240, and that equals 0.9x. So I end up with 288 equals 0.9x. Divide by 0.9 on both sides. End up with x equals 320. So the tower, and put up here, the tower is 320 meters tall. Okay? Alright, that is it for today. Have a great evening. I'll see you in class tomorrow.